Hello, sir. Good day, sir. I am John Villar Intera, and today I will gonna present my proposed small farm reservoir. So for introduction, small farm reservoir are designed to collect water for future purposes, such as water security that provides farmers with reliable and accessible water source for irrigation. It increase agricultural productivity by providing consistent water supply to meet the crop water requirement. This is a drought mitigation practice that result into efficient water management. So for the proposed location will be located at Puting Bato, Valenzuela, North Cotabato. So the soil type there is clay loam, and as you can see in the map, no, the yellow shaded area will be the service area, while the green would be the catchment area, uh, while the white in between of the service and catchment is the reservoir. So for the type of small farm reservoir, I propose a rectangular balanced excavation with a slope of less than 2%, storage ratio of 1.5. For the site location requirements, we have Puting Bato, Valenzuela, North Cotabato is the location. Soil type, clay loam, and climate is unimodal rainfall pattern. So now for preliminary design activities, pond dimension is 30 meters times 52. So the pond area would be 1,560 meters squared, height of 2 meter. In determining the freeboard, we have this formula of 1.5 times 0.032 square root of length of the dimension of the pond times the velocity, which is 9.36 kilometer per hour, plus 0.763 minus 0.271 square root of length of the dimension of the pond. So as a substitution, the freeboard would be approximately 1.1 meter. So for the volume of the rectangular balanced excavation, we have the surface area times the depth. So we have the volume of 3,120 cubic meter. So for the design height, so initial height plus the freeboard we have 2 meter plus 1.1 meter is equal to 3.1 meter. That is the design height. For the finish height, we have the design height plus the 20%, since it was according to PAES that the finish height would be higher to the design height by 20%. So finish height would be 3.72 meter. So now for the diversion, the depth of the diversion would be 0.75 meter. The width is 1.5 meter. The inside slope is 3:1. Outside slope is 2:1. Creased width is 3 meters. For the total rainfall per year in Puting Bato, Valenzuela, North Cotabato is 1,826.59 mm per year with approximately 5 mm per day. So catchment area of the location is grassland household. So catchment area we have is close to 1,560 square meter, all over 1,000 meters squared. So yun 1.248 hectare would be the catchment area. So estimate runoff from catchment area, we have 12,480 meters squared times the rainfall per day, which is 5 mm per day, all over 1,000 meter. So 64.4 meter cube per day. Multiply it by 30 days, so 1,872 cubic meter would be the volume of the runoff. So meaning having this 1.5 month to full the reservoir. Now for water crop requirements, the Tmin is equal to the temperature maximum plus temperature minimum all over 2. So the temperature maximum of the area is 34.32 degrees plus 22.88 degrees Celsius. For the T minimum all over 2, we have the T min of equal to 28.6 degrees Celsius. Now for the reference crop evapotranspiration, we have the formula of P times 0.46 T min plus 8. So 0.28 times 0.46 times 28.6 plus 8. So the reference crop evapotranspiration would be 5.92 mm per day. Now for actual crop evapotranspiration, we have the reference crop evapotranspiration times the crop coefficient. So the crop is a rice, no? So 5.92 times 4.81. So yun. Uh, we have a 28.47. So for crop water requirement, we have uh, actual crop evapotranspiration plus the seepage and percolation. So 28.47 plus 1.75. So we have crop water requirement of 30.22 mm per day. Now for farm water requirement, so land soaking requirement, we have a formula of N minus residual moisture content times the specific gravity times the depth of root zone all over 100. Now we have that given. N is 49, RMZ is 13, AS is 1.35, and VRZ is 30 mm. So since the area is a clay loam, so LRC, we have this substitution. So the land soaking requirement would be 94.35 mm. So for preparation water requirement, we have the LSR plus SW plus a reference crop evapotranspiration. So SW is equal to 10. So LPR as of substitution, we have the land preparation water requirement would be 110.1 mm. So for the effective rainfall, they have the formula of 0.8 P minus 25. So with substitution, yan, we have the effective rainfall of 113.264 mm per month. So for the preparation water requirement, we have the CWR minus ER plus CPWR all over application efficiency. So application efficiency of 0.6. So FWR would be 15.17 minus 113.264 plus 110.1 mm. So FWR for water requirement, we have 12.61 mm. So that is the proposal of the Small Farm Reservoir at Puting Batuman, Sinadric Cotabato. Thank you and God bless.